The first pod restarted at 9:42 a.m. No alert. Just a single restart event in Kubernetes. 5 minutes later, another one, then another. By 10:15 a.m., we had a pattern. Pods were restarting across one service. Still no alerts. Slack was quiet. Dashboards were green. But something was slowly going wrong. Environment context. We were running on AWS with Kubernetes on EKS. The application was a multi-service backend handling user sessions, notifications, and messaging features. Around 130 pods were spread across several services. Traffic averaged about 3,000 requests per second. The session service was particularly critical. It handled user authentication tokens and session state. It relied on Redis for storage and PostgreSQL for persistence. CI pipelines were handled through GitHub Actions. Deployments were managed via Argo CD. Monitoring was built on Prometheus and Grafana. We tracked CPU usage, memory usage, request latency, and error rates. Alerting thresholds were configured for high usage and crash loops. On paper, everything was covered. In reality, something slipped through. Initial symptoms. Users started reporting intermittent logouts. They would be active in the app and suddenly get logged out. Refreshing the page sometimes fixed it, sometimes not. At the same time, API latency showed slight fluctuations. Nothing major. Error rates remained low. CPU usage was stable. Memory usage looked fine at a glance. That was the key phrase. At a glance. Investigation and escalation. We began by looking at the session service. Pods were restarting, but not frequently enough to trigger crash loop alerts. Logs showed occasional out-of-memory kills, but not consistently. That was confusing. If memory was the issue, why were metrics not showing high usage? We pulled detailed memory graphs. That was when we saw it. Memory usage was slowly increasing over time, not spiking, not breaching thresholds, just steadily climbing, then dropping suddenly when the pod restarted, then climbing again, a pattern. We checked deployment history, no recent changes to memory limits, no obvious configuration issues. Then we looked at application logs more closely. We noticed repeated allocations of objects related to session tracking, but no corresponding cleanup. Root cause. The root cause was a memory leak in the session service. A recent code change introduced a new in-memory cache for session validation. The cache stored session metadata to reduce calls to Redis, but it lacked proper eviction logic. Entries were added continuously, but never removed. As traffic flowed, memory usage increased gradually. Because the increase was slow, it never triggered immediate alerts. Pods eventually hit their limits. Kubernetes terminated them with out-of-memory kills. New pods started fresh. Memory usage reset, and the cycle repeated. Because restarts were spaced out, they did not trigger crash loop detection. The system degraded slowly and quietly. Mitigation and recovery. The immediate fix was disabling the in-memory cache. We rolled back the recent deployment. New pods started without the leaking code. Memory usage stabilized almost immediately. Pods stopped restarting. User session issues disappeared. We then implemented a proper fix. The cache was redesigned with eviction policies and size limits. We also added metrics for cache size and memory growth rate. Once redeployed, the system behaved predictably under load. Post-mortem reflection. What actually failed was not just the code, it was our detection strategy. We monitored memory usage as a static value. But we did not monitor its rate of change. We had alerts for spikes, but not for gradual growth. We also relied on crash loop detection. But the restarts were too spaced out to qualify. The system was failing slowly, and our monitoring was not designed to catch slow failures. Engineering lessons. Memory leaks often manifest as gradual degradation rather than sudden failure. Monitoring should include trends and growth rates. Restart patterns can indicate deeper issues even when they do not trigger alerts. Application-level metrics should be tracked alongside system metrics. Systems can fail quietly when thresholds are not aligned with real-world behavior. That incident reminded us that not all failures are loud. Some of them grow slowly until they finally force the system to reset itself. Monitoring the quiet changes is the key to stability.